The tribe says, hit the like.
And greetings and welcome to Understanding Understanding. Can computers really think? We had a little setback here with the startup here, but we're going to get started right away without any introduction. I hope all of you are getting in here. I had to get the talking chat enabled as I noticed here that it was being mentioned here in the chat, and I want to make sure everyone's satisfied here with the performance of the technology, since we are talking about technology here in a sense. That said, what we're going to be going over here is over a paper that was from William Rappaport, written in 1995. So we're going way back here when you really think about the AI revolution that's going on today. And to think that this was written back in 1995, and I believe it was for the State University of New York at Buffalo, is about syntactic, semantics, and computational cognition. That said, I know they prefer the more erudite statements when they're at these, the things talking about the more academic ends of the philosophical perspectives and the connectivism and philosophical psychologies. Nevertheless, what we're going to be diving into here is how these have an intersection with a lot of things that we talk about here on this channel, specifically with the computer science, logic, and ethics. With that said, let's dive into it. If anyone is here, let me double check here, make sure we get the notifications out this time. And let's see here. And as soon as we get that going here, we're going to get started. Seems like we got some people in the house here. If you could.
Bill Simmons 4426 says greetings.
Excellent. So we are ready to go. Okay. Greetings to you, Bill Thomas, and everyone else that's here. Let's dive right into this. So the big question is, syntax by itself is not sufficient for semantics. That's from John Searle, the famous philosopher. And the translation here is, computers can only shuffle symbols around. They can never understand what those symbols mean. So syntax is the structure or the order of the symbols, and the semantics is the meaning of those symbols themselves. So the order or the way that they're structured or interconnected is a syntax. The semantics is the individual meanings of those symbols. And that came from John Searle, the famous philosopher, but as we know, these appeals to authority can sometimes be fallacious. So what if he is wrong? Let's start simple. What are we talking about? So, of course, we're not here for academics. We're here to get a full understanding, and this should be accessible to everyone. So syntax is the rules and structure. It's like grammar and language. The order you put things in English as opposed to Spanish would be different syntax. How pieces fit together. The mechanics, basically, of the language. In semantics, we're talking about meaning, what things refer to, what they're about, so to speak, and the understanding of what these things are. So here's an example of syntax is, the cat sat on the mat, follows English grammar rules. The semantics, it means a furry animal is on top of a floor covering. You see how that works? So the cat sat on the mat follows the English grammar rules. That's the structure. And the semantics is the meaning of it. So what do we get from it? It sounds nice, it rhymes, but it means that a furry animal is on top of a floor covering, which is a mat. Let's continue. At least in this context, I should say. And that's key, the floor covering, because a mat could be something else in a different context. So let's look at the Chinese room. This is Searle's famous thought experiment. So we have a nice little thought experiment here that, imagine if you're locked in a room. You don't speak Chinese. but then there's Chinese messages that are slid under the door. You don't have a giant instruction, or you do have a giant instruction manual in English, and the manual tells you, if you see this symbol, then write this symbol. So I don't know if the talking chat will talk this symbol. Let's give it a shot and see if it will.
The crime says.
No, it doesn't speak Chinese. So, as you see here, he doesn't have that giant instruction manual in English. So you can respond perfectly to the Chinese messages if you have the instruction manual, and the manual tells you, if you see that symbol, then write this symbol. But do you understand Chinese just because you have a manual that tells you, if you see this, write that? All right, let's move along here. So here's Searle's conclusion. The person in the room, he follows all the rules. The syntax is, if you see this, say that. And he gives the correct answers. However, he has no idea what anything means, the semantics. He has no idea what those symbols mean, and neither do I, for full disclosure. Therefore, the computers are like the person in the Chinese room. They manipulate symbols, but never understand them. So is the case closed, right? That the syntax alone isn't enough to understand the semantics, the meaning of the symbols, right? Is the case closed? Well, let's see. But wait, how do you understand? So we got a little pop quiz here. Oh, shoot, I still got this thing lingering here, don't I? Let's get that out of there. All right, so we have a little pop quiz coming up right now. And believe me, this won't detract from a special surprise. It's always waiting at the end. Nevertheless, how do you understand? And how do you understand the word cat? Think about it for a moment. The surprising answer: you understand cat by connecting it to other words: fuzzy, pet, meow, animal, memories of seeing cats, physical sensations, soft fur, and related concepts: dogs, lions, and mammals. So the key insight here is you understand words through their relationships to other things in your mind. You never touch an actual cat with your brain, only your internal representation of a cat. So the understanding is relational to your physical sensations in related concepts, memories, and other words, which are also some degree related concepts. So the understanding is relational. We're getting deep. Let's keep going here. To the fundamental principle of understanding. To understand something, you have to do one of the two things. One, understand it in terms of something else, like learning Ratchet means hunting dog. Or two, get used to it through experience, like becoming fluent in a language. So, two ways: understand it in terms of something else and relational, or get used to it through experience. So that physical sensations, other ways, in this case a mental exercise of becoming fluent in a language. But there's a catch. If you always understand things in terms of other things, where does it end? So we're looking at other things. Is it other terms or other experiences, right? Let's see here. Here's the recursion problem. When we look at it in terms of one thing, I understand A because I understand B. I understand B because of C. So I understand C, though, because of D. Well, I understand D. Well, because I understand D because of, it goes on forever. Eventually, you must understand something in terms of itself. You can't just constantly look at it relating to something else because this chain goes on forever. It's recursive. All right, let's move along here. And then the radical claim. What if understanding in terms of itself is just syntax? So they've gotten used to the system. They've gotten used to the system. The symbols have meaning through their relationships to each other. So this is an understanding in terms of itself. They've gotten used to the system. The symbols have meanings through their relationship to each other within a system. Think about the chess pieces. A beginner needs to see pictures. So we have our little chess icons here. A master plays blindfolded. Knight to c3. The master understands chess through pure symbol manipulation. They don't need that extra amount there to know it because they know the syntax so well. So now we're getting into a very radical claim that you're not needing that physical experience when you have the syntax understood so well. They've gotten used to the system. The symbols have their meaning through their relationships to each other. Very radical claim now. And let's meet Cassie, a computer mind. So researchers at Sunny Buffalo built Cassie, a computer system that reads English sentences, builds a network of concepts in memory, connects new words to things it already knows, and learns meanings from context. This is 1995, so we're going back 30 years. So this is the concept network. It's like a brain made of connected nodes instead of neurons. So you see here is Cassie, and it has word and dog and all these different nodes here, but they're conceptually related. 1995. So how Cassie learns, an example. There came a white hart running into the hall with a white brachet next to him, and 30 couples of black hounds came running after them. Cassie thinks, I don't know brachet, but it's near a hart, a deer. The hounds run after it. It seems animal-like. Maybe it's a type of dog. And I guess Cassie doesn't like spaces after these words here, but at least they're highlighted for us to see. The learning process is after 18 more encounters with the word, Cassie builds connections. So it takes a threshold. It forms a network of relationships, and then a pattern emerges. Cassie concludes, a brachet is a hunting dog, and that's exactly what it means. So, look at that. You can see how all this stuff really originated as far as the machine learning. The dictionary insight. So, how do you use a dictionary? Think of it like a vase or a vase. It's a container for flowers. A container is a receptacle for holding things. And then what's a receptacle? It's a container. So you see this recursive type of relationship here. The insight is you look up an unknown word. You look up unknown words using words you do know. So it is circular. But it works because the circle is huge. So we see that threshold with Cassie. It was 18 examples there, but with a dictionary, it's a huge circle. So your understanding becomes a giant web of interconnected meanings. This is where it all starts to click. And you can see how the computers work. Now, with the Helen Keller moment. Remember Helen Keller at the water pump? Well, if you don't, she was there with whatever, the trainer there, and water was flowing over one hand, and the teacher spelled water in the other hand, in her hand, the palm of her hand. And that was the breakthrough, because the physical sensation, the physical experience of the water became relationally associated with that spelling of the water in the hand. The symbol connection was made in the breakthrough. She connected two internal experiences. One, the physical sensation of the water, and two, the finger-spelled pattern. Both were already in her mind, but understanding what happened when they linked together is what occurred. So we have these moments, the Helen Keller moment, so to speak. At least that's the terms the authors chose to use. Then we have the mind-world gap. This is the Smith's gap. Here's the problem. Your brain never directly touches the outside world. Everything you know about the world is actually just patterns within your brain. Look how we perceive. Light hits your retina. Signals travel through neurons. Your brain builds a model of reality. And then you think this model is reality. Think about that. Light just hits your retina. That signal travels through neurons. Then it gets to your brain where it builds the model of reality. And then you think that this model is real. All right, on to the next one here. The symbol grounding problem, though. The critic here says, but symbols need to be grounded in reality. Your word cat needs to connect to real cats in the world. So what's a connection to the real meaning? The symbol grounding in reality problem. The response is how? When you see a cat, you see, well, I don't know about photons, but you see the light. Then there's retinal image. Then there's neural signals. They get to your brain, you have that mental representation. So even grounding happens inside your mind. So even when you are actually with a real cat. So there's this gap, the Smith's gap. That's what we call it here, right? Mind world gap is a generic term, but also Smith's gap. But the mind world gap, it's always present, because even when you're there next to the cat, it's still not touching your brain. It's still a mental representation, albeit it is grounded in reality as far as we could tell to the highest degree, but it is something that is still a mental representation. So let's look at the big picture of this. Understanding is like a web. You have words related to other words. All of these words and the other words are all related to internal concepts and sensory memories, which were built from experiences, physical experiences, which were also represented internally. All this together leads to our patterns and relationships and pure syntax. It's connections all the way down. All right, so we see the big picture. So isn't that really just circular?
Raphael minus 777L says, if consciousness stands forever separated from reality by interpretation, is meaning something found or something in post to survive the gap?
That's an interesting one there too. I'd say that meaning probably needs to be more carefully defined here, because as we're seeing here, we're trying to reach at what meaning is. Is meaning based on purely on the what we would say is reality, or is it somewhat built on the syntax or the mental representation? I think what we're actually leading here to is the quality of the way it's being mapped to being as accurate a representation of reality as it can be, because I don't think it ever can be. You know, there's a saying that the map isn't the territory. However, as we're going to see here, that's the challenge for any kind of machine language learning or machine-based learning. So yeah, good question here, but stay tuned here because we're going to get deeper into that right now. So again, that reasoning here becomes circular if we just keep doing the relationships here. Let's go back to this slide just to review this here and to see this here, that the big picture is seeing it's an interrelated web and connections all the way down, but it could be seen as being circular because where do the connections end? Eventually, they're going to be coming back around. So, all right, let's get these slides going. The circle becomes, so the key here is that if it's circular, the answer is yeah, but it's still okay, because if you think about something like becoming fluent in French, at first you translate chat equals cat. Eventually you just think in French. Chat means, I'm not saying this right, what a chat is in your French thinking mind. The circle becomes so large and rich that it contains meaning. So at first you're doing these translations of syntactical type translations like the guy in the Chinese room, not really having a full knowing of the meaning at first, just having it, he might know some of the stuff here, but until he's made that connection, there is no understanding of that word. Eventually he does. He's actually thinking with those French words, and then chat means what it is in, no, I'm not saying that right, in his French thinking mind. So the circle becomes so large and rich that it contains meaning. So it's the syntax that's building up the meaning, the dictionary that's building up the meaning. Of course, it's all circular. All of these are circular, but the size, there's that threshold just with Cassie having to reach 18 interactions to build, to figure out what the hatchet was. All right, now we're on to the algebra analogy here. Remember solving for x? I love it. X equals 4y minus 3 divided by 2. You can't solve this without knowing why. Why would you want to? Okay, so x equals 4 minus 3 divided by 2. Now you can solve it. You know everything else in the equation. So it's the same with word meanings. If you have an unknown word, context equals known values, right? The context provides known values that lead you to solve for the unknown word. So what we call context clues have enough known values that allow you to basically, with a high degree of reliability, predict or discern that unknown word based on the context clues. So the context provides the known values that let you solve for the unknown word. Understanding is solving for meaning using the surrounding context. Wow. So understanding is solving for meaning using the surrounding context. Interesting concept there too. Let's move along. So what about computers? 1995, granted. Can Cassie really understand? If she passes the Turing test, convinces you that she's human in conversation, then Cassie builds a network of concepts, learns from context, makes inferences, revises beliefs, and communicates successfully. Does it matter that her thoughts are electrical patterns instead of neural ones? Wow, now this is 1995. We're already looking at this stuff here. So let's see what the answer is to this. The shocking conclusion. Semantic understanding is syntactic understanding. Oh, so the meaning is understanding the syntax. Meaning isn't some magical extra ingredient. Meaning is the role a symbol plays in a rich, complex system of symbols. So whether that system is made of neurons or silicon, it can still understand. So our question, again, just for clarity here, can Cassie really understand? That's the question. And the shocking conclusion, according to this, says that whether it's made of neurons or silicon, it can still understand if it has a rich, complex system of symbols that give meaning to the role of the symbols. So by the system of connections gives meaning to those individual symbols. So let's continue on from here. the response to Searle, we get at the beginning, remember the Chinese room? The person in the Chinese room doesn't understand Chinese. But what if the room itself does? The system understanding. It's not the person. It's not the rule book, but the whole system. The process of matching symbols to responses within a vast network of relationships. That system might genuinely understand. So we're kind of taking this to another step here and seeing it as the room itself and not just the rule book, not just the person. So without taking anything in the isolation is the response here and seeing the big picture. Let's move along. So the implications, if this is right, artificial intelligence is possible. Computers can genuinely understand. 2, that human understanding isn't magic. It's just incredibly complex pattern matching. 3, meaning is relational. Nothing means anything by itself, only through connections. And 4, understanding is a matter of degree. The richer the networks, the deeper the understanding. Remember, the understanding happens after that critical threshold. So with enough syntactical connections and individual experiences, that those rich networks can be developed, and that leads to deeper reasoning. So I guess what it really comes down to is it's not just whether the computers understand, but how deeply do they understand, and how rich are those networks of connections, and how valid are they. So let's continue on here. Or I should say how true they are in relation to actual physical reality, which again is part of mental representations or enough people that agree on it to be objective. All right, let's look at some mind-bending questions here. If machines can understand, do they deserve rights? Can they be conscious? Are we just biological computers? If understanding is just syntax, what makes human understanding special? Is there anything unique about consciousness? This is where philosophy meets computer science and meets ethics, where you're not going to hear spoken about anywhere else that I can think of. So salute you all being here. Here's your take-home message. You thought you needed syntax, the structure, plus the semantics, the meaning. But we found that rich enough syntax is semantics. Complex enough connections create meaning. The map becomes the territory. Everything makes sense. The question is, what sense does it make? And that comes from Stuart C. Shapiro. All right, and that takes us to the best part of the presentation for those of you that are still here, the Chinese room thought experiment. We're going to take a short quiz here. For each of these questions, you'll see the number highlighted here in the upper right. That's the number of the question. You don't need the 0 there, but we play this by putting it in the chat, the number of the question, and then the letter of the choice you select. So if you're doing question 1, you'd put in the chat 1. If you're selecting D, you'd put 1D delta into the chat, and that would be your answer. If you want to revise it, just replace it, and the last one you put up will be considered the final answer. We'll tally up at the end, and let's get started. According to Searle's Chinese room thought experiment, why can't the person in the room understand Chinese even though they can produce correct responses? A, because they don't have enough time to read the instruction manual. B, because they only manipulate symbols without understanding their meaning. C, because the Chinese messages are too complex. Or D, because they don't have access to a Chinese English dictionary. So what's the correct answer here for, according to Searle's Chinese room thought experiment? Why can't the person in the room understand Chinese? Even though they can produce...
Minecraft Fafo says 1B.
All right.
Bill Thimmeth 4426 says 1B.
All right. So we got a Minecraft says 1B, and Bill Thomas says a 1B. Excellent.
Craig Curry G5E says 1B.
All right, excellent. So we have everyone agreeing to 1B. Let's move on to the next question. So we're on to question 2. Come on. There we go. The recursion problem. All right. The presentation argues that understanding must eventually end with understanding something.
Raphael minus 777L says thank you for that. I think it is 1B.
Yeah, I think we can stick with 1B on that. But, you know, we can always you can always revise that if anyone changes their mind, but I think that's a pretty safe pick. Let's move on to the recursion problem. Question 2. The presentation argues that understanding must eventually end with understanding something in terms of itself. This creates a recursion problem, though, because infinite loops would cause the brain to overheat. B, computers can't handle recursive definitions. C, if understanding always requires understanding something else, where does it end? And D, that's a D there, recursion is computationally expensive. Now remember, this is 1995, so this is according to this presentation here. So I guess that could be a valid choice. But again, choice A is infinite loops would cause the brain to overheat. B, computers can't handle recursive
Bill Thimmeth 4426 says 2C. Raphael minus 777L says Raphael minus 777L says
Yeah, I'll agree with A there. Okay, so, but we had one for...
Minecraft Fafo says 2D.
2D, recursion is computationally expensive. It might have been back then, but you know, it's, think about also that computers can't handle recursive definitions. I don't know about that. And then C, if understanding always requires understanding something else, where does it end? We're looking at the recursion problem. It says that understanding must eventually end with understanding something in terms of itself. And we saw many ways there that it creates a recursion problem. That said, let's move on to the next question.
Craig Curry G5E says 2C.
2C, all right. So we're on to question 28. Casey's learning process. So has Casey, the computer system, learned the meaning of the word ratchet? A, by looking it up in a digital dictionary. B, by connecting it to related concepts through context in multiple examples. C, by being directly programmed with the definition. Or D, by asking human users for definitions. So we have A, looking it up in a digital dictionary. B, by connecting it to related concepts through context in multiple examples.
Bill Thimmeth 4426 says 3B.
All right, 3B. Yeah, the related concepts through context.
Craig Curry G5E says 3B.
All right, we have a few votes for 3B.
Raphael minus 777L says B. Minecraft Fafo says 3B.
Fafo, all right. So we got 3B. It looks like a pretty good consensus here. Let's move on to the next question. Question 4, which is going to be our final question here. As soon as it comes up, there it is, the shocking conclusion. The presentation's shocking conclusion suggests that A, humans and computers understand in fundamentally different ways. B, semantic understanding is actually just syntactic understanding.
Raphael minus 777L says C.
And C, is this for, you put the question number in there. You got to put a question number. This would be question number 4, and then your letter answer. So you go ahead and do that again just so we're not confused at the end when we tally up. Okay, so the presentation's shocking conclusion suggests that A, humans and computers understand in fundamentally different ways.
Raphael minus 777L says 4C.
Okay, 4C. All right, well, B is semantic understanding is actually just syntactic understanding. C is only humans can truly understand meaning. Or D, computers will never be able to understand language. All right, let's move on to the solutions here and the answer key. And final call
Craig for EG5E says 4B. Bill Thimmeth 4426 says 4B.
All right, so we got our final answers in. Let's move on to the answer key. So question 1, according to Searle's Chinese room thought experiment, why can't the person in the room understand Chinese, even though they can produce the correct responses? And the answer was B. Because they only manipulate symbols without understanding their meaning. So this is the answer for question 1, is the person follows syntactic rules perfectly, but has no semantic understanding of what the symbols actually mean. And as we saw before, if the syntax is the semantics, then why doesn't he have the meaning? Is because it's not rich enough. He hasn't passed that threshold. Even Casey or Cassie needed 18 interactions to figure out of context to figure out the meaning of one symbol. So to figure out what Bratchett is, it needed to have 18 examples to figure that out. So with only one example here of syntax, it's not enough to give any semantic understanding. All right, let's move on to question 2. The presentation argues that understanding must eventually end with understanding something in terms of itself. This creates a recursion problem because, and the correct answer for 2 was C. If understanding always requires understanding something else, where does it end? If understanding always requires understanding something else, this creates an infinite chain that must eventually end with something understood in terms of itself. So this is the recursion problem here. All right, on to question 3. How does Cassie, the computer system, learn the meaning of the word Bratchett? And the correct answer was B, by connecting it to related concepts through context in multiple examples. Cassie learns by building connections between unknown words and known concepts through repeated contextual exposure. Through repeated contextual exposure, keywords there, to the word in different sentences. All right, so that was B for 3. And for question 4, the presentation's shocking conclusion suggests that the correct answer was B. Semantic understanding is actually just syntactic understanding. Meaning isn't a magical extra ingredient, but rather the role a symbol plays within a complex system of interconnected symbols. And as the philosopher Cassira said, that we are creatures of the symbols, that we no longer interact with the real world in terms of itself, that we only do it through our symbolic system, so to speak, whether through language, art, religion. It's always through something that's a symbolic construct, and that we can no longer deal with reality on its own terms. So that we're actually, it's a different almost species of humans. It was the Homo symbolicum, I think he called it. Nevertheless, that'll be a topic for another one.
Minecraft Fafo says, hit the thumb up.
Yes, indeed, please do. And definitely subscribe and hit the bell notification if you want to get notified for more of these. I like to have the interactions here as we did here live. And I thank you all for putting in all the contributions here.
Bill Thimmeth 4426 says, it might be fair to ask if thought is required for intelligence.
Well, that's a whole nother topic, isn't it? Because we've taken our first step to getting to understanding, and the thought to intelligence is another step that we'll have to investigate as we can go deeper into these topics here. This is a paper that I found some time ago. This is from 1995. So just think about...
Jack says, interesting.
Hey, Captain Jack, ahoy! Greetings to you. Good to see you here. Uh, yes, definitely the to think that 30 years ago that this was the cutting edge kind of systems of computers that were being used, and it doesn't seem very much more advanced than what we're looking at today. So you can only imagine what's lurking behind the scenes. That said, I digress here, and that's of course just my opinion. But we can go deeper into some of these documents that actually have practical applications and the descriptions and explanations of how these things actually operate.
Raphael minus 777L says thanks the tribe a big virtual karma $111 super chat heading your way. Minecraft Fafo says was this an article you had laying around from 95?
Wow. Well, thank you for that generous offer there. This is a article that was I haven't had it since '95, but somewhere around there. It came out in 1995, so this is something that's been out there for a long time. This comes under a
Raphael minus 777L says also because it is January 11th, also known as 111.
there you go. Thank you. All right, so we get that clarification. Yes, indeed, it is January 11th now that we've passed that midnight mark here in the Eastern Time Zone. So yeah, indeed, there's a lot of different aspects to the machine learning, the ontology alignment, and languages that were used for this that I have some text on, and some other graduate level books that delve into this. That I'm going to look in for more topics that kind of uh, that relate to this in ways that apply to the way we're using these tools today, and to give us just a better, as you might say, an understanding.
Bill Thimmeth 4426 says MIT made the ELIZA program to explore AI in the 60s.
Indeed, ELIZA was something that was such a short amount of code that was just amazing the way it had the conversational abilities. And I think it was supposed to be a cognitive behavior therapist or something like that that was programmed in there because it was very systematic, and they were able to get it to do the get that conversational element weaved in with the responses that were working on an underlying you'd say a
Bill Thimmeth
syntactic structure.
4426 says indeed.
Yeah, and it was something that was almost just like a game, something people just do to play around with. But it was totally locally run. It wasn't something that was online that you would run it on your own computer, whether it be the old Apples or the Radio Shack computers. They were. It was something that for its day was very advanced for a computer to be doing. And if you had the voice synthesis module on it, boy, it was really spooky because it's like you're talking to someone. That said, we can see where things were really actually released very long ago that haven't changed very much to what we see on the outside here, just little superficial changes. The backbone of it, though, and to think about it like this, let's say there are the same systems. If that syntactic relationship database has been growing over 30 years, that gives a higher degree of understanding and a deeper understanding. Remember, the amount of the syntactic connections leads to the deeper understanding, and the semantics of it is based on the level of the syntactic connections that can be made in relations and the systems, relations between subsystems, and all of that adds to deeper and deeper understanding. With 30 years of this being developed from where we're seeing right here that we went over on this presentation, it doesn't take much of a stretch of an imagination to see how much more is available than what we see on the surface. With that said, I thank you all for coming here, and I'm going to dig up some more topics on this that have been, I guess you could say, below the radar, so to speak, but definitely applying in our day-to-day lives.
Raphael minus 777L says I am taking in the understanding necessary to understand and understand the understanding of these profound systems. Bill Thimmeth 4426 says fun topic. Take care all.
You too, and greetings and thank you, or I should say thank you for you all and salute to you all for being here, and hope to see you all on the next one. Peace out.
Raphael minus 777L says salute. Subscribe says, hit the like.